So, I am introducing some terminologies. You will find these references here in these papers. Okay. Let me show you those first. So, these are the 4 papers that I have used in the session. One is the very important paper that you should read, and it is available publicly. And then the second one, distributed representation of words and phrases and their compositionality. Okay. So, this is something that you should definitely read. Okay. This paper talks about word to vec, and then the third one talks about the hierarchical distributed models, how the trees can be, how you can place the words in the binary trees in the hierarchical fashion. And then this is the original patent filed by Google. This also gives you information about how these processes are completed in terms of finding the word vectors. Okay. So, those are the 4 papers that you should definitely read in order to further understand this and so on. Okay. So, I also would like you to listen to one of the lectures, I think it is 7105 from NPTEL on deep learning. Especially on the hierarchical softmax. So, it briefly explains the theory of the hierarchical model, and that would also be a good reference for you to understand this material. All right. So, this is another one that you can read. Okay. So, now let us introduce some terminologies and then see how the weights can be updated in this model. All right. Let LW be the number of nodes to traverse to the word from the root node. Okay. So, let us say that there are, in the case of the 8 node, we have the length as 3. Okay. And we generally represent that as every node as n w comma I. So, it is the ith node on this path, and the associated vector for this node is v n w I. Okay. Suppose if this is node 2, okay, and that corresponds to the second row of the context matrix. Okay. And then CHN is the child node. Okay. So, now the probability can be found based on whether whether we are going to be traversing to the left or right. So, what is the decision that we are making from one node to the other. So, the decision that we are going to make is, do we have to traverse to the left or do you have to traverse to the right. Okay. And then this is given by this condition here. Okay. Going to the j plus 1th node from the child node. Okay. So, if it is equal to if this is going to be traversing to the left, this will be equal to 1. Okay. And then if it is, if the jth node or j plus 1th node, in order to reach from the child node j, and you have to move to the right, then the value is going to be minus 1. Okay. So, this is the equation for you to find the probability. It is a generalized equation. Okay. So, in this case, if you look at this, I have taken this is v dash n transpose dot product of dot h. Okay. And then this h is nothing but the row in the embedding matrix. Okay. So, in this case, as I mentioned, if x is true, if this condition is true, so we just are going to be representing this as x. Okay. That is sigma x okay. So, if this x is true means we are from node parent node to the child node we are traversing to the left, right. If x equal to -1 we are traversing to the right side. Okay. So, in that case I think I spoke about this as well here. All right. So, now how do we update this? We now know how to compute the probability from the root node to the word that we have in question. We also know that when you take the sigmoidal of the value which we can represent as uk for simplicity's sake, okay, sigmoidal of uk plus sigmoidal of. Okay, so, this is easy to prove. Okay. If you want to find out the probability of the word given the input word as given in the example, it is going to be first you remember we are going to be traversing from the left. I think this is how it is. So, this is our root node 1, 2, I think this is 5. So, we move here, that is to the left. So, there is no change in the sign of the equation that we had shown earlier, and then from here we are taking a right. So, there is a that x brings in -1 here, right, here -1 and the last one equal to 1. So, this is an example that we have used earlier. Okay. So, for that for you to compute the word 3, okay, so we can use this model. Okay. You got it. So, once we know the probability of each of the word computed using the sigmoid through the values that we have gotten from the output layer, now it is time for us to really find out what is going to be the error and how do I minimize the error so that the network learns. Okay. The error is again given by the negative log likelihood. So, now when you want to find the error, we now have to apply a different conditional stuff. So, when we move from the bottom, we have computed the probability of the word and we know that it is not the right value, because initially when you initialize all the weights in the embedding layer as well as in the context layer, it is definitely not going to be corresponding to the word that we are inputting. So, there is going to be some error there. So, how do we correct the errors? So, when we go back from the bottom to the top, right. So, we need to make some changes. So, when we move up there, so we need to assume that the values are not right and some changes have to be made. When we computed the left node probability, we actually find the right one by doing this operation, right. So, when we move up, we know that we value has to be changed, and then when you take the partial derivative with respect to the uj, this is what you get and this condition comes out of that. Okay. And when the condition is equal to 1, that means it is the left node, this is the equation that we need to look at. If we have moved right, then this is the equation that we have to look at. Okay. So, in general we can term it as Tj. So, instead of this, we are now moving it into a standardized notation where the dou E by dou uj will be equal to sigmoid of uj minus tj. Tj is nothing but a value which will be equal to 1 if you are traversing to the left, right. I am sorry, if you are traversing to the left, yes, and if you are traversing to the right, it is going to be 0. So, that means we are making some changes in the values when we move up, and the values are updated using this equation. Okay. And the new value Vj new is this is old, is computed using this. In the same fashion like we have done earlier, the changes of the embedding weight should be done with respect to the partial derivative dou h. That is, we are trying to change the weights based on the error with respect to this, right, which is EH. I think we have derived this earlier, and the weights in the embedding layers are updated using this formula, and you know what this eta is all about. Okay. So, this is a complex part. Okay. So, I like you to really go through this video a few times, read the reference material that I have given and try to understand this. So, this is the core of the recent trend. Okay. This is what is used in the NLP nowadays. Okay. So, this derivation, the reduction of complexity and the neural net model is very important, and you need to have a clear understanding of that if you want to really take it to the next level.